Yeah, I was here. Yeah, I was doing things yesterday. No, I needed the time. Contrary to popular opinion, I'm actually a pretty busy guy. All right, here we go. You need some formulas. And by the way, okay, if you get to a point where you're like, oh, this is starting to feel a little bit challenging, that's good and that's normal. Okay? And we are at that point to where we separate from the regular track trig class. Okay? So if you're taking trig without credit, they wouldn't cover this material that we're covering. So really from here to the rest of the year, that's where you're earning your college credit, which is 4 credits right now, right? 4 credits for trig. That's what you're getting. Good deal. $3,000. Let's go. All right. And with inflation, it keeps going up, right? Last semester was 3, and this semester is 4. So you get 7 for this year. Yeah, that's pretty good. All right. Here we go. Today we're going to do sum and difference of trigonometric formulas. Sine of a plus b. Do not write this down. It is not equal to sine of a plus sine of b. If you write that down in the test, I will probably start crying because that is just totally illegal. It's almost like you said, hey, we're going to distribute the sine to each one. I mean, totally voodoo math. Can't do it. Yep, I'll get out the red pen and I will try to make you cry when you read the test then. Okay, so just to be clear, so that we understand why, if you had 3 times x plus 6, everybody, that would be 3x plus 18, right? Because the operation is multiplication. There's no multiplication as an operation. The operation is sine. Sine is the operation. So to just bring it, I've never actually thought about this before, so instead of 3 times, it would be as though it was just like an operation of times. Like, what would you distribute? You know what I mean? That wouldn't make any sense to you. And in this situation, there is no multiplication. It's just sine of this. What is the answer? Sine of A times the cosine of B. Plus cosine of A times sine of B. And there is a proof for this. I did it a few years ago. It's tough. It isn't easy. Not many of us would follow it. So I say that we skip it. And if you want to see it, come and see me later.
I'm not seeing you later for that.
You're asking why, and then I say I would have to show you the proof. It would take us 45 minutes. Yes?
I'm wondering why you just told us that sine means like it's like an operation, but you literally just told us that it was also like x over r or y over.
Yes, that's the operation. Yes.
Right? Yeah.
No, it's a division operation. It's a ratio. Sine is a ratio. Yep. Yep. Okay. So if it was subtraction there, then it would be subtraction here. Okay. So plus minus follows plus minus. As I write out the next one, I'll answer Marissa's question as well, which is why do we need to know this? You don't know this to be successful in life. I already told you guys that I had somebody, at the meat market who didn't know that 2 3/4, he thought it was 2.325. Get it? 2 3/4. So he didn't know that 2 3/4 was 2.75. So you don't actually need to know anything in life to be successful. Like you could just go through life not knowing how to do anything. So, but if you are wondering why we do this, the answer is this class is called pre-calculus. The whole precursor of this class is that you were trying to prepare to be able to do calculus. If you don't know how to do trig, calc is going to be no bueno. All right, so we have cosine of A times the cosine of B. And instead of plus, it's minus sine of A times sine of B. And it does work out in this situation that if you were to change this to minus, then this would be changed to plus.
So are those like both the same?
Even though they're like in different order, are they the same or no?
Is what the same?
Like sine A, cosine B, and then cosine A, cosine B. Like if you're adding them together, when you get
Like you could flip those and flip those if you want. Multiplication is commutative. Is that what you're asking? Okay, then they are not the same. We'll go with that. All right, here we go. So on your sheet, we have this piece right here. We are currently working in the sum and difference formulas area. And so that's what we're working with. So as you deal with sum and difference formulas, I do every once in a while get somebody who takes a test. They don't do well. And I comment to them, I said, you actually you didn't even grab the right formula. And they say, I don't even know where to find the formulas on this page. If you don't know where to find the formulas, this is going to be a really tough test. So hopefully if you're needing a sum and difference formula, you know to look here. Okay. So we come back to this piece, and we're going to try example 1. It says, find the exact value of the following. Exact value, meaning no estimation. Sine of 23 times the cosine of 67 plus the cosine of 23 sine of 67. Does that look familiar? Yeah, look at what Marissa has done. She says it looks like this formula. It looks like the sine of an angle times a cosine of another angle plus sine or a cosine of an angle times sine of that other angle. And she says we just learned that that formula is equal to the sine of A plus B. So if I want to determine this exact value, all I really need to do is just recognize that and then determine A and B. What is A in this problem? A is 23. What's B? So we have sine of 23 plus 67. What is 23 plus 67? 90. And what is the sine of 90? 1. That's it. Does the next one look familiar? Does that look like your cosine sum and difference formula? Very good. So this looks like the cosine of A times the cosine of B plus the sine of A times the sine of B. And we learned that that was equal to the cosine of what? A minus B, but there's a plus sign. So we do the opposite, right? Yeah, very good. What is A and what is B? So A is 2 pi over 3, and B is? Good. So we have the cosine of 2 pi over 3 minus 5 pi over 12. Four. So cosine of 8 pi over 12 minus 5 pi over 12. And you get what? What is 3 pi over 12? Cosine of pi over 4. Pi over 4 is how many degrees? 45 degrees. And do you remember what the cosine of 45 degrees is? Okay, all right, I'm going to write it out. We got it. I was expecting a few more to get it, so we're just going to draw it out real quick. Remember, if you have a 45-degree angle, what we are looking for in this situation, this is 1. That's the root of 2 over 2. That's the root of 2 over 2. So this terminal point is root of 2 over 2, root of 2 over 2. Remember, cosine is which value, the x value or the y value? And what's nice about 45 is it doesn't matter if you remember that or not, because it's just going to be root of 2 over 2. So we have root of 2 over 2. Look at that. Man, you guys are smart. Look at how good you are. You know, there's those angles like 90 degrees and 30 degrees and 45 and 60 that we can find exact values of. But when we talked about that unit circle, we didn't talk about 15 degrees, did we? No. What if we wanted to find the exact value of sine of 15? Well, there's no special right triangle. Like here we drew a 45, 45, 90. Or we could draw a 30, 60, 90. But there's no 15, 75, 90 special triangle, is there? There's not. So what do you want to do? Are there two angles that add or subtract to 15 that you know the exact values of? 45 minus 30. So let's expand. How does sine of 45 minus 30 expand? Sine of 45 times the cosine of 30. Good. Now, we've all talked about 45 degrees already, right? What's the sine and cosine of 45 degrees? Root of 2 over 2. See how this is kind of going back and reviewing a little bit of what we did at the beginning of the year? And now we need 30 degrees. If you consider a 30-degree angle, we got root of 3 over 2 and 1/2. So that's the terminal point for 30 degrees. So what's the cosine of 30? Root of 3 over 2. And what is sine of 30? So order of operation says we're going to multiply first, and then we'll subtract. Over 4. It's okay, I've done the same thing before. And so we get the root of 6 minus the root of 2 all over 4. Take out your calculator. So I'm going to go ahead and I'm going to type in sine of 15. And I get that. And notice if I take parentheses, the square root of 6 minus the square root of 2, and then I'm going to divide it by 4. That ain't no estimation, is it? That's the exact value. Yeah, everybody goes straight for the fraction. I'm going to say it's a radian. How's that? So would you like to take the radian and convert it to degrees, or do you want to deal with the radian? Okay, so how do we convert a radian to degrees? Forget how much you remember. You knew none of this before you came into the class. You guys are just rattling it off right and left. So I've got pi divided by pi. Those cancel. And 180 divided by 12, you know, is 15. Times 7 is 105. So this is the cosine of 105 degrees. And we know 105 degrees is not one of those nice angles that we get to work with. But maybe there's two angles that add or subtract to 105. 45 and 60. 60! What? See, at this point on my YouTube channel, I need to put a link there so people can then click on the Girl Scout cookie fail. Yeah. Just think of how many people are watching right now. Right? It's like at least nobody, right? Okay. All right. So cosine of 60 plus 45. Great. Expand it. Great. So I've expanded it. We've already talked about 45, haven't we? Very good. Cosine is sum and difference formulas. You switch the positive and the negative. Whereas in sine, you keep it the same. So we know 45 degrees is the root of 2 over 2. But now I have to look at 60. Very good. Luke says 1/2 and root of 3 over 2. So what's the cosine of 60? 1/2. And the sine of 60? So cosine is the x value and sine is the y value. It's okay. It comes as at a good time. It's going to help us remember some things we've done. So I get what? Over 4. Very good. Minus. And I get root of 2 minus root of 6 all over 4. Not bad, huh? What's that? Yep. In this situation, I see this as this could be positive or negative. Everybody see it's going to be negative, and that makes me feel a little bit awkward because I'm like, can it be negative? So let's think about the original problem, cosine of 105. 105, first quadrant, second quadrant, where? Second quadrant. Is cosine positive or negative in the second quadrant? It's negative, so I should get a negative result. Hey, look at how I verified, my solution a little bit. Okay. As we flip it over, I've decided to make a deal with you. I'm going to make this. I'm going to give you guys the sheet of notes on the test. How's that sound? Yeah, I just want to remind you, you get the sheet of notes on the test. You good with that? I'll make another deal with you. Instead of having you make it on your own, I'll just give it to you. How's that? You good with that? I just want you guys to understand that I'm trying to make this as pleasant as possible, okay? All right? Okay. So remember to see the bright side of things, okay? You don't have to memorize all the formulas, and you don't have to make your own sheet. We need to go to the exact value of tangent now. So the tangent sum and difference formula is a little bit different. So as we get ready for this, let's actually write down the formula, and that would be right here. Sum and difference formula for tangent is as follows. The tangent of A plus B is equal to the tangent of A plus the tangent of B. Is that nice? Divided by 1 minus the tangent of A times the tangent of B. It sure is. If this is plus, then this is plus and this is minus. So if it's minus, then this turns to minus and this turns to plus. And again, I'll go back to it. But so that one is then located right here along with your sum and difference formulas. Sometimes people are like, if they're written down here, why do we write them down in class, Mr. Gens? Studies show you remember it better if you actually write it down. So that's why. Can we jump to the back page?
What is the plus sign on the bottom?
Right here? It's a T. Multiplication. No, you're not. Nope. No, I don't think you're stupid at all.
Just like write it better so my small brain goes.
I like the idea. I'll throw a multiplication sign in next time. Okay, so as I look at the exact value of tangent of 19 pi over 12, and you'll write this down in a second, but right now let's focus on 19 pi over 12. You would want to turn this into degrees, right? So we take 19 pi over 12, and we multiply it by what? 180 over pi. Excellent work. So the pi's cancel, and 180 over 12 is 15 times 19 is, so I have the tangent of 285 degrees. So go ahead and write down 0, 30, 45, 60, 90. Write down those values of angles that we see within the unit circle, okay? Those are all the angles and values that we see within the unit circle. I am from Minnesota. Yeah, always. It's always a hot dish. It's always a casserole. What is it? I don't know. I didn't realize that. I didn't realize there were rules. You guys got to inform me on this. Okay. I knew it was tater tot hot dish, but I don't even like tater tot hot dish. Like, nah. Yeah. Okay, well, you can live in crazy world if you want, but I'm going to live in reality. Here we go. So, here's what I want you to do. I want you to find two angles that either add or subtract to 285, and once you find one set, find another. Go, talk to your peers. Find them. Go. Okay, what do you got? What's that? 225 and 60. What else you got? 135 and 150. 240 and 45. 330 minus 45. Okay, we all get the idea? Okay, there are good choices and there are bad choices. Okay? So I used to just let everybody just figure this out on their own, and we're kind of running short on time. So I want to make sure that we see the good choices and the bad choices, and I just want to help you out, make life easier. You okay with that? And I'll show you. 225 and 60 is a good choice, and 240 and 45 is a good choice. That's a bad choice, and that's a bad choice. Now, you're wondering, how do you know the difference between a good choice and bad choice, right? And that's because of this, and I'll show you. And you don't have to write all of these down, but I just want you to understand. The tangent of 0 is 0, and the tangent of 90 is undefined, and the tangent of 45 is 1. So obviously, 0 is a nice choice, and 45 is a nice choice, but 90 is not a good choice, is it? Now, the tangent of 30 is the root of 3 over 3. I'm sure you all remember that. And the tangent of 60 is the root of 3. So I ask you, would you rather be working with a 30-degree angle or a 60-degree angle? Everybody see that? That way I avoid the fraction. So I like working with 60 and 45 especially. And then if you carry it along, 120 is negative root of 3, 135 is negative 1, 150 is negative root of 3 over 3, and 180 is 0. So again, I don't like 30, and I don't like 150. 210 is negative, or is positive root of 3 over 3. 225 is 1, and 240 is the root of 3, and 270 is undefined. So you can see I don't like working with 210. And 270 is undefined. 90 is undefined. And then 300 is negative root of 3, 315 is negative 1, 330 is negative root of 3 over 3, and 360 is 0. So you can see I don't like working with 330. I don't like working with 30. I don't like working with 150. I don't like working with 210. And I don't like working with 330. I do not like green eggs and ham. I do not like them, Sam, I am.
Is that something that we can put on our notes?
Right now, no, but maybe I'll change my mind. Thank you for asking. Okay, let's help you in your confusion. Here we have it. You guys told me choices. I want to do the tangent of 285. Tangent of 285. And you guys said I could choose 135 and 150, but do I want to choose 150? No, because the tangent of 150 is negative root of 3 over 3. I don't like it. But could I choose 240 and 45? I like that one. So we get the tangent of 240 plus 45. Let's expand our tangent sum and difference formula. What's the top going to be? Over what? What's tangent 240? Close. Square root of 3. What's the tangent of 45? 1. I know. 1 minus. What? Root of 3? Can I leave that as my answer? No, I can't. Why? Square root of the denominator. I have to rationalize the denominator. How do you rationalize the denominator? Times it by the conjugate. When you don't know how to do the math, do the Spanish, folks. Multiply top and bottom by 1 plus the root of 3. That will allow the square root to disappear, and the middles will cancel because we're multiplying by the conjugate. Let's see what we get. FOIL out the top. Square root of 3. Not plus 9, plus 3. Plus 1. Plus root of 3. And in the denominator, 1 minus 3. Very good. What do you get in the top? 4 plus 2 roots of 3 all over negative 2. Cool. I want to be clear. You can do this problem using 135 and 150. It's just a little bit more involved. I used to just have the students just figure it out on their own and go through the pain. I'm like, let's just teach them how to avoid that. Laura likes that. She appreciates that. Thank you, Laura. All right, last one. You have 10 seconds to tell the people around you how you feel about this word, which is proof. Okay, go. All right, here we go. Here's what is great about a proof is that you were given the start and you were given the end. So in other words, you know the answer. You know the answer. You know what you're supposed to come up with. You're supposed to come up with cotangent. And notice it's saying prove that the tangent of pi over 2 minus u is actually equal to the cotangent value. That's what we would like to do. But there's a problem here. And the problem exists in the tangent sum and difference formula. Because right now, your first reaction would be to set this up using the tangent sum and difference formula, right? But look at what we come up with. We come up with tangent of pi over 2. Pi over 2 is how many degrees? 90, and the tangent 90 is... So it doesn't really work to use the tangent one, but I know something else about tangent. Tangent is the same thing as sine divided by... So let's do that. Let's do sine of pi over 2 minus u divided by cosine of pi over 2 minus u. I now could expand that, right? And when we expand it, what are you going to get on the top? Sine of pi over 2 times cosine of u. Good. Then? Good. Sine of pi over 2 times cosine of u minus cosine of pi over 2 times sine of u. And then what's on the bottom? Now, oddly enough, this is where most students get, and then like apathy just sits in, and people are like, "I'm done. I can't finish this off." And actually, it gets really good from this point on. It's really nice because pi over 2 is how many degrees? 90. What is the sine of 90? 1. What's the cosine of 90? 0. So look at what you've just said. What is the sine of pi over 2? 1. What is the cosine of pi over 2? 0. Cosine of pi over 2? 0. Sine of pi over 2? What happens if I multiply something by 0? It goes away, right?
Why are you keeping with the sign of u?
Well, what is 0 times the sine of u? And then what's 0 times cosine of u? So what are you left with in the top? You have 1 times cosine of u. So you get cosine of u in the top. And in the bottom, you're just left with sine of u. Which, isn't that what we wanted? Is that what we were told? Now you're kind of at that elite level mathematics standpoint where you're in trigonometry, you're preparing for calculus, you're doing proofs. You're kind of bona fide math geeks. Okay, that's what you are. And so I'm going to tell you something that's kind of a little bit elite status as mathematicians. You get to end your proofs. And there's a few ways you can end your proofs. Like, how do I say that I'm done with this proof? And one way is you can write QED. It's a Latin acronym for that which was to be demonstrated has now been shown. Sometimes people don't do that. Sometimes it's customary to put a little box there, and that's a sign that you're done. Almost like you boxed your answer or something. Sometimes I actually saw my professors, they put a box, they'd check it, and they'd smile afterwards like, ah. I mean, the different jokes you get at that level, right? So I had a professor once upon a time, great guy, one of my favorite professors, Mr. Zorn, if you're ever listening. His name was Dr. Zorn, and Dr. Zorn had a doctorate in mathematics as well as English, which is really hard to do, okay? Like, super, super, super smart guy. He wrote our 3 calculus textbooks, okay? That's the kind of guy he was. So he's teaching us a different class in a theory course, and he's going up to end his proof. You got to remember, when we were doing the proofs in his class, because he had a doctorate in math and a doctorate in English, he would first go through and make sure that it was mathematically correct, and then he would go through and make sure it was grammatically correct. And because he did that, we actually got both a math credit and an English credit in the math course. That's how much proof writing there was. But he would come up to the board and he's like, how do I end the proof? And we were like waiting for some new way in which you'd end his proof. Is he going to write QED? Is he going to do the box? What do you do? And he'd look at it like he was thinking of something really profound to do to end his proof. And finally he'd just write, and he'd write done and he'd walk away from it. So you can do that too, I guess, if you want. I don't care. It's kind of a stature thing, though, to end your proof. It's like...
I was going to say, is that something that you require on the test? I mean, I have to remember that after, burning my brain up.
You're not going to remember to write done or, put a box? You're not going to remember that? Good. Yeah, sure. All right.